Hi, good morning. Hello?
Hi Smith, how are you?
I'm good, thank you. I was a bit concerned that nobody could hear me then.
Yes, I can hear you. Wells is there and Mr. Srinivasan is there. Wells, you are in mute.
Hi, Mr. Smith. Good morning.
Hello,
How
sir.
are you?
Morning.
Bills?
Yes, sir. So we have already
We are
started
good to go, sir.
admitting the students. We have already started admitting the
Well, sir,
students.
we are good to go, sir.
Okay. Good morning, everyone, and welcome to the Motor Vikatan Automotive R D Design Workshop, which is supported by Mahindra and Mahindra. And it gives me a very great pleasure in inviting you all to this workshop because some time back, say some 2 months back, we held another session. At that time, some 3,500 people turned up. Now you have turned up in very large numbers. I strongly believe the seats for this big attendance is only because of the seat that you have shown some 2 months back by Mr. Veluswamy sir. Thank you, Mr. Veluswamy sir. You are standing with Motor Vikatan in helping the Motor Vikatan to fuel the scientific passion among the student community. The student community is our strong base on which the Motor Vikatan is standing. Uh, the automobiles, science, Mahindra and Motor Vikatan makes up a very big team. And we welcome you all. And we have, to give you a formal welcome address, we have our editor of Motor Vikatan, Mr. B. Srinivasan. He is also managing director of our Vikatan group. I welcome Mr. B. Srinivasan, our managing director, to give you a formal welcome note.
Yeah, good morning. Good morning, everybody. Welcome, Mr. Smith, Mr. Veluswamy. Mr. Smith is joining us all the way from London. It's 5 o'clock in the morning for him, and I thank him for taking time this early on a Saturday morning. Thank you very much for being with us, sir. I think with Mahindra, this partnership, the outreach to students has been extremely successful, and I think the proof of the pudding is in the eating. From a few thousands a couple of months back, today we have over 15,000 registrations, and I think it really shows the kind of interest that the student community has. I'm very glad to be partnering once again with Mahindra, and very glad to have uh, extremely august speakers on board, and especially Mr. Smith, who's going to be telling us a lot. I think today the entire world is focused on the future of automobile, which is basically the electric cars, and I think nobody better than Mr. Smith, to give us his perspective on it. And Mr. Velusamy is very well known to the readers as well as the student community of Motor Vikatan. And I request him to start off with a welcome note. I think all of you have been waiting for a very long time. And Mr. Velusamy, it's over to you.
Thank you, sir.
Thank you. Thank you, Mr.
Go ahead, sir.
Thank you, Mr. Srinivasan. Thank you, Mr. Wells. It's wonderful always to interact with Vikatan group. Thank you for nominating me as one among the top 10 Tamil future leaders. It makes me so proud to be associated with you, and humbled that you are recognizing the efforts of many individuals. Thank you very much. Readers, wish you a very happy Pongal and Makar Sankranti, whichever part of India you are celebrating festive seasons. Best compliments and wishes for your festive seasons. And to start with, we decided along with Mr. Srinivasan and Wells that, for example, we try to give a lot of lectures, but we said we will bring in a lot of experts who worked in various fields. So there are 5 experts that we have nominated to begin with. They are basically into various fields of expertise. They will share their knowledge from their experience. For example, Smith, who comes from UK, he worked in our Pininfarina when we created the Pininfarina high performance electric car. He was the brain behind for the platform. So he has a very rich experience in creating a platform for electric vehicles, and he has a rich experience, and he is now currently developing 2 of our most ambitious electric vehicles, and he has an insight into what it takes to develop an electric vehicle. So he will share a generic knowledge on what it takes to develop, migrate from an IC-based vehicle to an electric-based vehicle. What are the challenges that occur when you take the electric vehicle technology into our prime movers. We also have people specializing in architecture, occupant comfort, convenience, and the interiors design, exteriors design, connected car technologies, ADAS, and sunroof integration, panoramic sunroof integration and stuffs like this. Gesture control, emotion readings, facial readings, all these stuffs will be taken by Binay. We also have people who put the technology, people, and process together to create a product. Co-creation, we call it as a co-creation. Mr. Naveen Chopra will take a session later in the series. We do have people specializing in CAE analysis and CFT analysis and methods, 1D calculations. Dr. Kailash Sharma, who is a veteran in doing crash analysis, NVH analysis, architecture analysis, strength analysis, durability analysis, putting all the analysis together and determining what is the least section that we need for weight and cost. So the CAE is a very, very integral part of our design and development. We have people from there. We have people from powertrain. So various experts will come and speak to you. But my appeal to you is to assimilate, and what it resonates with you, what it resonates with your passion is what you need to pick it up. You need not be an expert in every field, or all that you need to be an expert is one of the fields and shine in one of the fields. Bring your ideas to the best of the society, and the society can benefit out of you. It's no secret that Albert Einstein is not a doctoral degree holder, and it's no secret that many of the scientists, Galileo, for example, who is the starting point of every scientific revolution. Even for Newton, when he invented many things at the age of 16 to 21, I don't think he has achieved, he got the doctoral degree. He got the doctoral degree later. Smith is right, sitting from UK. He would know about Newton much better than me. But 2 things I want to leave you. If you think that everything is already achieved and there is no scope for further achievement, what Albert Einstein did was that he proved beyond anybody's doubt that what Newton thought, there are some corrections needs to be done. So that's the level of scope available. And what Albert Einstein thought is the end of quantum mechanics. Niels Bohr, Heisenberg, Dirac, all those scientists have proved Albert Einstein. Maybe Albert Einstein lacked understanding of quantum mechanics, and today quantum mechanics and quantum computers are ruling the world. They are going to rule the world. They are going to come. So every scientist, when they were at the peak of their careers, what seemed to be that we have reached the complete understanding of the cosmos, complete understanding of the whole thing. Again and again, history has proven that there is further possible to improve, and these contributions of these scientists prove that even the scientists lack understanding at certain point in time, and the new generation of scientists can prove better than the old generation of scientists. So I have no doubt, all of you, the students who are joining, you will prove us, you will better us, and you will show your incredible innovation skills, creativity skills in creating a better automobile product for environment, for people, and for the society. I am very, very sure. What's very important for us is to put the fuel to it, and that is what we are trying to do. So I want to highlight the difference between innovation and creativity before before I end the session to hand over to Smith. It is always told that the creative people are different and the innovative people are different. In my view, the creativity and innovation occurs in every street and every corner of a village and every street in a town and a city. Let me say it in this way: that you are hung up, you are obsessively possessed, thinking about a problem to find a solution. That's the starting point of a creativity. That is the starting point of an innovation. What happens is that when your whole mind, left brain and right brain, are thinking about a problem, they are going to connect the unrelated dots of the problem and trying to find out an unimaginable solution by somebody else. By linear logarithm, linear mathematics, you cannot find a solution. But you have to find a solution by connecting unrelated dots, and suddenly you will find there exists a solution. That is what people call it as a creativity. If you are asked to say 1 to 5 and you say 1 to 3, 4 is an obvious number before you go to 5. So therefore it's not an innovation, it's not a creativity. But if you were to find out a logarithmic scale, if you were to find out the Raman series or the Ramanujan series, a very simple series that you can calculate all the addition of the numbers. So that is kind of innovation. That is kind of creativity. So it takes all of your brain to work on that problem for so long time. This is called fluid state. People call it as a fluid state, where there is no traffic signal. There are no white marking in your high line of thinking. You think haphazard. You are completely thinking unrelated things. You get into a jungle, you think about that problem. You get into an aeroplane, you think about that problem. You go to a mall, but your mind is thinking about that problem. The mind is thinking on its own, not by force, because of the passion that you are thinking about it. Suddenly you will find something in the mall and you will correlate with the problem that you are thinking, and by correlation you will find a solution. This is called creativity and innovation. What it takes is just to focus on the problem and try to think about the problem and try to find out a solution. Now, this part, please remember, does not have any rules, any regulations, any procedure, anything, nothing. It is not an army order. You just think about this problem, whatever way you want. You just roam around, but your mind is spinning around it. That's how the creativity is. All that it takes is your interest to solve that problem is the starting point for creativity and innovation. Suppose you find in an EV vehicle or an IC vehicle that this problem is hurting the customers, and so therefore I want to solve it. That's your starting point. You will find it solutions when you get onto your train or get onto your plane or get onto your parallelism. You will draw and you will find a solution. Now the innovation part is nothing but once you get an idea, how you convert that innovation, the creative idea, into a workable solution. There will be limitations to the creative ideas, but when it comes to innovation, how do you get it done and make a prototype, and how do you implement, how fast you implement into product? That gives some income to the companies. So the creative part is the most intelligent part of it, most procedure-less part of it, driven by passion, driven by interest, driven by intelligence, driven by your perseverance. But the innovation part is once you decide the idea, And when you implement, it is driven by procedures, it is driven by process, it is driven by discipline, it is driven by hard work, it is driven by how much money I put it and how much money I will take it out. So you have to switch your brain from a free radical to a bound radical between creativity and innovation. And you should be able to flux your mind between creativity and innovation when you are an engineer. You want to be a very successful engineer, you create an idea with a free radical mind and get into a train track and reach from point A to point B. That is innovation. Now, from this series, you need to identify, when Smith is talking, you need to identify what are those problems where you want to apply creativity. And if you have a solution, and that solution, how you want to implement it. You can work on both the problems. That's all about engineering is and generating future. And I wish you a good luck. Thank you, Vikatan, once again. Thank you, Mr. Srinivasan. You are a wonderful, wonderful, wonderful personality. This noble cause of educating students, which is there in US, UK, Europe, very much you are bringing to India, and I'm very, very proud of you and Mr. Wells and your team. Extremely proud of you. Educating students is not an ordinary cause. It needs noble mind. Thank you very much. And Smith, thank you very much for waking up very early in UK, from UK, and trying to share all your experience in the electric domain. Thank you very much. Wish you all the best, students.
Thank you, Mr. Veluswamy.
Thank you very, very much. To say the least, we are dumbstruck. We have never heard such a simple explanation about what makes an engineer. Thank you very much, very, very much for your words of wisdom. I hope there are many engineers sitting in this room. And the most exciting part is we have sent only 1,500, Zoom IDs. But I think more than 40% has turned up in the Zoom. And there is amazing number in YouTube. And even the rate of attendance is very good when compared to all the other previous workshops. And thank you, audience, for making this happen. And that shows your level of interest. We want to motivate, we people and motivated want to see your faces so that we can get motivated, so that we want to conduct this kind of workshops again and again. Is it possible, if you don't mind, is it possible for us, for you to to unmute your camera for at least 10 seconds so that we will be excited and motivated and we can carry on with the session. So okay, there are a lot of students. So what percentage of you are students? If you are a student, why don't you just type it out, I am a student, in the chat box, so that we will know how many students are here and how many the freshers are here. And if you are a fresher, type fresher. If you are a student, type student. Or if you are an automobile professional, type professional. So that gives a fair idea of whom Mr. Smith is going to talk about, whom he is going to address. So now he is getting a fresh idea, so that I think he will talk to you in a language which you understand. Thank you very, very much. Thank you very much. And before Mr. Smith takes over, I just like to, before introducing him, of course, he needs no introduction. He needs no introduction at all. He is known to the automobile world. And of course, when it comes to electric vehicles, I think he is one of the leading personalities all over the world. But anyhow, I need to introduce him as formally because I was told so, because he needs no introduction, as I said, but still. Mr. Michael Smith, we are very proud, to host you today in the first session. And he is the Chief Platform Head for the electrical vehicles, commercial, and as well as the passenger segment, and the product development and automotive division. Okay. He has started his career in 1980. Oh, that is, he has spent at most four decades in this field. He joined the Ford as an apprentice and then as an undergraduate. After graduation, he started with Ford in engineering, product planning, and value engineering. He then moved to Bentley, the most exciting brand, and performed many roles in product planning, vehicle architecture, change management, training and development, problem solving, but mostly in project management. And in 2013, he joined this iconic company, Mahindra and Mahindra, as a project leader, and helped to set up Automobile Pininfarina, which is a mecca for automobile lovers. And that's where he planned the portfolio of the future products, and he was a project leader for Batista, and led the vehicle architecture for a family of new battery electric vehicles. That is his forte now. He has spent most of the time on all the stages of a vehicle project delivery, from planning, architecture, design, development, launch, and warranty. So during this time, he has worked on over 30 vehicle programs, from commercials through the premium, luxury, and hyper-performance electric vehicles. He has also lived and worked in UK, Italy, Germany, and India. So he has got, a wide knowledge. He has traveled. He is a mostly traveled person. And certainly everyone now in this world wants to learn more and more about the electric vehicles and how the future is going to be. And he has already lived 40 years in the automobile world in the past, and he is going to project us how the next 40 years is going to be. Mr. Smith.
Many thanks, Wells. Thank you very much for that introduction. Yes, 40 years. And
Mr. Smith, sorry. And
Yeah.
before that, just I forgot to make one announcement. And there are a lot of students here. You see, we have structured the program in such a way that you will be getting, the students will be getting, if you are very keen in getting the e-certificate, and you should, as a student, should follow some basic rules and discipline, and you should be attending all the 5 sessions on all the 5 Saturdays in full. So we'll be giving a link at any point of time in this chat box, wherein you have to fill in that form. So the filling that the form will help us to monitor your attendance. Of course, it's not I don't want to sound academic, but still we need to follow some rule. So we need to, because we want to be very specific, are very interested in giving a certificate to you. So for this, you need to attend all the 5 sessions in full. So you can expect the Google form at any point of time, and the Google form will be deactivated within half an hour once the session is over. So make it a point that you fill up the form, and you also make it a point that you mention your name with exact spelling in which you want the certificate to be. So that's it. If you have any doubts, just put it in the chat box. Sorry, Mr. Smith, now you can take over.
Okay, many thanks, Wells. Thank you for that introduction. I can't believe it's 40 years. I can remember almost just leaving university back in 1987 as a graduate. So I fully appreciate the position I think the students are in India. And many thanks for joining this morning as well. That's I'm not sure whether the number is meant to overwhelm me or to make me go quiet, but I hope you can learn something from today. And I like to also refer back to Velu for his very good introduction. I sometimes can be too creative, and people will probably comment on that. But one of the comments that Velu made was about you don't need to be an expert to be able to solve these issues, and he referred to Einstein as somebody who studied. He wasn't an expert, but he became well known in his field. Okay, so I'm going to share my screen and move into the presentation. That's okay. 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 One of the common questions now is, can you see my screen?
Yes, Mr. Smith.
Yes, sir, we can.
Thank you. Thank you. So e-mobility in the future. So I'd like to run through a couple of points here at a high level. A little bit more about some of my background, and then talk a little bit about why electric, why e-mobility, and then give an overview of e-mobility, and then look at the history of electric vehicles, and then spend some time just going through some of the basics of the system, just to get a feeling and understanding. We can then talk about, I've got the EV future, but also the normal, this new normal, and then wrap up to talk about electric vehicles and your future. Can you hear me okay?
We can hear you, sir. We can hear you.
Okay, good. So, as Val said, I joined Ford in 1980 until 1995 and worked on a variety of products. Here you can see some of the products. They look very dated now, but I can tell you at the point in time, they were really exciting. Worked on the power steering installation of the Ford Mondeo, the product planning of the Ford Transit, which was a tremendous product with some hundreds of body styles and multiples of powertrain and some calculated 7 billion build combinations. In 1995, I was recruited by Rolls-Royce and Bentley, and you can see some of the products that I worked on here. So I was the engineering change manager for the Rolls-Royce and Rolls-Royce Seraph and the Bentley Arnage. But I became very associated with the new generation of Bentleys, the Bentley GT. You can see the convertible, that's the super sports convertible, and the premium model that we had, the Mulsanne. I was the very first Bentley employee to drive the very first Bentley Continental GT way back in Germany, in ERA, which is the test track that Volkswagen have. But in 2013, I was made an offer, a very kind of interesting proposal and a great opportunity to work with Mahindra and Mahindra, and involved on leading a project which isn't shown here, but what I am showing is the XUV 300. I played a part in some of the architecture of that vehicle to help define the stance and the appearance. And then in 2017, I went to Italy, to Pininfarina, and together with a small group of people, we helped to create Automotive Pininfarina. And what is shown there is the vehicle that was codenamed at the time PF0, but Battista. Some 1.4 megawatts of power, a tremendously exciting product. But after that, I came back in 2019 for me to work on, and it might sound a little bit strange, but to me, to work on even more exciting projects that I'm not going to go into the details now, but the opportunity to influence and deliver EV to a much wider group of people fills me with a lot of passion and excitement. So yes, I came back in 2019 to work on the new projects. So why are we talking about electric mobility? This just gives an indication of the problems that we are facing today. This is an analysis, a global analysis of where we are emitting our greenhouse gases. And you can see this was done in 2016, this analysis. And as you can see, the lines are just going in the wrong direction. And transport is around 8 billion tons in 2016, and that's not showing any signs of dropping. The effect that this has is we see our global temperatures rising. Big problems. We might not think it's so much of an issue when we're in the UK, where it's, I think at the moment is about 5 degrees centigrade outside, but it is an issue. And one of the reasons why it is an issue is that we've seen this continual rise of sea levels, which causes major problems around the world, and quite locally, I think Bangladesh, it's very severe. People think that this CO2 concentration, it's cyclic, and as you can see here, it is cyclic. But since we've been producing carbon dioxide, you can see the effect that we've had on the world's climate. And there's a source there. If you wanted to get some more data on this, you can see the source, Our World in Data, which will show you this analysis. You can take this analysis, I think just linking back to what Velu was saying, you could do a correlation analysis and just check the data, but you can see here this high rising CO2 concentration, and this is something that we need to do. We need to work on. And just to try and put that previous graph into a little bit more local perspective in terms of time, essentially from what's termed the Industrial Revolution in the late 1800s, you can see what's happened around the world globally. So that's trying to explain why in terms of some of the data. And this is showing as well something that we're probably very familiar with. Certainly in Delhi, what we're showing here is, in fact, the image that's shown is an image that was taken on the left-hand side or at India Gate. This is probably quite a normal site, but the right-hand side, that is what happened after we went into the lockdown. Excuse me a second, I'm just trying to, okay. Yeah, I couldn't see the right-hand side of my screen, apologies for that. So this is what we saw on the right-hand side after the lockdown was introduced, and quite refreshing to see that kind of environment. And you're probably very aware of the kind of pollution levels that are in the city. Okay. That's a little bit of background about why we're doing this and why we're focusing on e-mobility. So e-mobility, just to give some kind of an overview, we can look at it in, I put down 5 different areas here. We can talk about e-mobility on the land, on the road, on the water, on rail, air, and I've included, I'm going to bring a pointer up now, this element too, which initially you probably would say this has got nothing to do with mobility. But I think in the recent 9 months, 10 months or so, we have seen this play a big part in mobility. And then if we start to look at some of the areas around this, and I'll just run around this. In terms of the road, e-mobility, yes, this is taking place and it is picking up. As we move around this side, when we get into water, we see there are actually some ferries, commercial ships, excuse me, particularly in and around Scandinavia, where these ships will ferry cars and people over reasonably short distances and can charge their batteries when they dock. At this point in time, I've put a question mark here against the large ships. You will go online and you'll find images that show solar panels across the deck of a large ship. But at this point in time, these are not really really functional. They're ideas. Private craft, yes, that's covered. Rail, covered for many years. I'll go back across to this side where we talk about in the air. And there are, I'm going to call them low load systems or low load aircraft. people are familiar with drones, and drones are being considered for by companies like Amazon to deliver their parcels. And only a couple of years ago, there's a small aircraft, Pipistrel, which has achieved the licensing requirements to be able to fly. At the moment, this flight is only a very short range. It has about just over an hour of flight time, and is used for training. But we have an issue here, which is about high loads. So this would be commercial airlines. And it's believed that to be able to achieve this, you need to be somewhere in the region of 400 and probably more watt-hours per kilogram. This is a term that you do find used. You'll see watt-hours per kilogram. You'll see watt-hours per dollar. This is a metric that's used to understand battery capacity. Just excuse me a second. And then if we come down to the bottom left, virtual, well, we're all on Zoom, people are on YouTube, and there are many different, hesitate to use the expression platforms, there are many platforms, and we have become very familiar with them. Even the old greybeards like me have been using these things for quite a while now, and we're all very used to having meetings, having reviews, having social exchanges using these tools. But the focus that I'll be putting will be around these the road vehicles. Clearly, I'm working with Mahindra and Mahindra, but the purpose of this page is just to show, let's call it opportunities, other areas of interest that will contribute to e-mobility and therefore contribute to the reduction in CO2. Okay, EV history. I think most people are well aware of Tesla, and probably a few people actually think that electric vehicles really only started with Elon Musk taking the first Lotus and putting a battery pack in it, but it actually goes back a lot further than that. So this is an indication of the history of electric vehicles, and believe it or not, they were actually the first vehicles, non-horse driven vehicles. And in 1880, the first product was launched, shown, and driven. And there's you can see these essentially were like what we would call horseless carriages. So the horse had been taken off the front, and a motor and battery pack had been included. In terms of volumes, probably very low. But in and around the 1910s, there was a proliferation of these electric vehicles. I think in New York, there was somewhere in the region of 30,000 of these on the roads. And they were starting to become quite successful with that kind of volume, replacing the horse-drawn carriages. But then along came the internal combustion engine, and the increased range and increased performance of the internal combustion engine put paid to the electric vehicles. So there's a piece of history that we almost saw electric vehicles steal the show way back over 100 years ago. Things were ticking along with some electric vehicles, electric concepts. This here is a group of postal delivery vehicles in Germany. And then it wasn't until the end of the millennium where we had the GM Saturn. And this is then the point in time where we started to see this upward trend of electric vehicle sales. Excuse me. And we're seeing at the top here the Tesla Model 3, which is the best-selling EV in the world, just recently passed, certainly in Europe, the Zoe. So that's the longer-term history, and then this just gives you an idea of the current size of the electric car fleet. So we're now over 7 million vehicles. 2.1 million vehicles, just over 2 million vehicles shown sold in 2019. And this gives an indication of the different markets. So China is by far and away the largest EV market, seeing considerable growth. It's picking up in Europe and even in the US. In the US, there's a big love for the V8 engines, for the ICE engines. And even though this is, I'm going to call it Elon Musk's home territory, we're seeing this increase, and this is a global figure. So over 7 million vehicles now. So that's a little bit about the history. And what I'm going to go through now is some of the basics of the electric vehicle layout. So what you can see here are some of the elements that go into making an electric vehicle, and we'll go through a few of these as we progress. I'm not going to go through all of the points. It looks complex, and yes, it is complex. But in terms of moving parts, it is a fraction of the number of moving parts you'd find in an internal combustion engine. So what that means is we should see a longer lifetime, longer durability of the motor transmission system, just by basis of the number of moving parts usually is proportional to the amount of warranty and problems that we have with vehicles. So one of the benefits is that in terms of e-mobility is that if we have the motor and transmission lasting for a longer period of time, then we don't need to replace it. If we're not replacing, then we're not reusing, we're not spending additional energy in producing these kind of these systems. Okay, so what I'm going to do now is just run through at a kind of a high level some of these areas. So the first area we'll look at will be what we call the battery pack. Here it's consisting of the cell monitor unit and the battery modules, and throughout this vehicle you'll see these CAN lines, these communication lines. So typically this is the main elements of a battery pack. We have the electrodes connecting to the battery cell, and at the bottom you'll see different types of cells. You have a cylindrical cell, prismatic cell, and a cell known as a pouch type cell. All of these consist of different layers of material, which you can see unwrapped here in the cylindrical cell. Now, just to make life interesting, they introduce a few little different terminology. So these are known as the form factors, and the form factor is basically just the shape of the cell, the shape and the dimension of the cell. They could have said the shapes, but they decided to call it form factor. And I'm pretty sure somebody will give you a really good reason why we want to confuse people with different terminology. So the electrodes go to join up with the battery cell, and then what we do is we group these battery cells together into a module. And this module then can be arranged in series or in parallel within what's known as the battery pack. This reason why we align them in series and in parallel is to support the voltage requirements of the system and the total amount of available energy. Excuse me. Then within the battery system, we have this a very robust battery housing, which protects from the bottom, from impact, from grounding, and around the sides, also to protect from side intrusion. Battery cells, if you ever, I don't advocate doing this, but you can find where battery cells have been pierced. And when that happens, there's an instantaneous release of energy. And cells can go into what is known as a thermal runaway. And there are instances of this happening. And I think we have learned over the years the catastrophic effect that this can have. You can probably check and find online where a jumbo jet, a Boeing 747, was brought down by a thermal runaway of battery cells that it was transporting, and that brought the plane down. So we have these robust battery housings on the top, on the bottom, and around the side, and then we seal the pack. And the specification, there's a specification IP67, which talks about moisture and dust ingress into any system. But the idea is that this is completely sealed from the outside against moisture and against dust ingress. We have in here as well a battery management system. This battery management system essentially controls the cells, ensures that we have good cell balancing. If you've ever replaced the batteries in a unit, I'm not sure if it's shown so much now, but it definitely used to be the case that when you change batteries and you were putting 4 batteries in, it said change all 4 at the same time. Reason why you change all 4 at the same time is you don't leave one weak cell in there, because that weak cell will detract from the performance of the whole system. And what will happen is they will try and reach this this constant level. So what the battery management system does, it monitors all of the cells within the battery pack to ensure that we don't have particular cells running down too low. And also that when we're charging the battery back up, that we're charging it at we're charging the cells that might have dropped a little bit further to get them back up to a nominal condition. Within this battery pack, typically we have a cooling system, and this has just been shown here as a vertical panel, but this is a schematic. You will find these sitting usually underneath the battery pack. And I still need to challenge the manufacturers of battery packs to understand why the cooling plate is at the bottom, because we know that heat rises. But the cooling plate typically sits at the bottom of the battery the battery pack, beneath all the cells, and is connected to an external source that we would either use to heat or to cool the battery pack. And you'll see here we've got cooling plates down the side, but the systems that I've seen have got cooling plates under the bottom of the battery pack. And then all of the cells, there's buzz bars that run down the unit to connect the batteries in series, connect the battery modules in series and in parallel, and there'll be an output connector on this. This is just to give you an overview of what goes into a battery pack. So I mentioned about the different cells, and there are many different types of energy storage systems, and this is typically how we like to display things. So I mentioned before about the watt-hour per kilogram. If you recall, I was talking about approximately 400 probably required for commercial aircraft, 400 watt hours per kilogram. And you can see at the moment, we're not quite at that level. And then we have specific power, watts per kilogram. So this is how much energy we can get out of the battery pack at a point in time, joules per second. When I was at Automobili Pininfarina, I mentioned about 1.4 megawatts, but we also wanted to have a sort of 140 kilowatt hour battery pack, 120 kilowatt hour battery pack. So top right is what we would call as the ideal position to be in. We can get as much power out of the battery as we possibly can, and we can have as much energy stored within the battery. And what you'll find as well is that some terminology, I'll just basically touch on this, which is the C rating of a cell links very much to the amount of power you can get out of the cell and the amount of power you can put into the cell. So as you can imagine, if we want to have very quick charging time, then you want to have a cell that can charge at a very high rate. If we want to get as much performance out of the vehicle as possible, we want as much of that energy to go out of the cell to drive the vehicle. So that is around the specific power, and then the specific energy is essentially how much energy the vehicle can contain. And if we look today, this is usually will be communicated in kilowatt hours. And the biggest kilowatt hour we know at this point is around 100 kilowatt hours, which you will find on the Tesla Model S and Model X. So these are different battery chemistries. I'm not a battery chemist expert, but lithium ion seems to offer the best compromise. There'll be some other elements in there. There'll be cobalt used too. This is the traditional lead acid battery that you would find as what we call a low voltage system of around 12 volts. Lithium ion battery packs. At the moment, the biggest battery packs are 800 volt battery packs, which is on the Porsche Taycan. But most of the industry is moving to around about 350, 400 volts. So this is the battery cell of choice. There are other developments, and you will see other developments online, and they're great. We'll have these not magic, that's not the right expression. We'll have this new technology, and people will talk about this new technology, how it will be 300, 400 watt hours per kilogram. And all they need is $500 million to be invested to bring it into production. So you want to be looking out for those, but at the same time, this is where the future is going to be. So things like carbon nanotubes, we've got supercapacitors. This is a form of capacitance. So you can think of batteries as essentially an energy storage, chemical energy storage. Here's a mechanical energy storage, a flywheel, and then this is looking at capacitors. Okay. I see that somebody's raised a hand. If we can have questions at the end, please, that would be the best way to move forward. So we have a device called an inverter. And essentially what the inverter does is a switching device. It takes the direct current from the battery and converts it to alternating current. And this switching element here, it would be around about the let's say the end of, but in the 1990s, where we had commercial applications of MOSFETs. These essentially would allow very rapid switching of the DC to allow an effective electric motor to operate, an AC motor. This essentially is what we'd call the drive. This is taking the DC power, switching it to operate the AC motor, and then in regeneration, this flows back through through the motor, through the inverter, and back into the lithium-ion battery. Like many systems within the EV architecture, the inverter also has a cooling circuit, and you can find that the inverter can actually limit the performance of the vehicle, because this needs to be cooled, needs to be kept at a certain temperature, all the way through from the battery through to the inverter to the motor. All of those elements need to be considered when you're looking at the total power output of the system. Okay, the motor and transmission. So this is just an image of a motor and transmission. This is the motor element, okay, and the transmission. Then you see the differential on both sides. So the differential allows the wheels to operate at different speeds. But the motor essentially now has moved to AC to remove any brushes, any contacts that can wear out. And there are several variations of permanent magnet motor. From my perspective, I'm as primarily a vehicle person. You know, I'm looking at the best solution here that can give us the best, the most effective to manage the ratio of function and cost. So as the engineers develop better motor solutions, then we will take those on board. And as I was saying before, the transmission motor also have a cooling circuit, and typically we find the inverter mounted as close as possible to the motor. We have extremely high voltage. We have that extremely high voltage flicking backwards and forwards, and when that is happening, we get a level of EMI, electromagnetic interference, which, as you noticed in the image before, where we were talking about the CAN systems, you need to shield as much as possible this CAN system from this high voltage fluctuation. So if you imagine if the inverter was positioned, let's say at the back of the vehicle or away from the motor, we'd have these long lengths of high voltage cables, which would be having an EMI around these cables, which would have a disastrous effect on the rest of the vehicle. So we keep them as close as possible, and you usually find it's a combined unit, motor and EMS and inverter. So within the system, we have what I'd call battery condition. We have a compressor to cool the battery pack, and we have a heater. This will obviously provide cooling when the battery pack is in hot climates, but will provide cooling at times when we are charging the battery. That could be charging with a quick charging solution with a high DC current. This could be cooling during regeneration loads. So the more energy we can get back into the battery, the better. And there's always a balance between the operations of these systems. There's a whole team, whole industry, which is around this energy management of the vehicle. And these two are a significant drain on the energy management, which is why we're now seeing the heaters being replaced by These originally a PTC heater, positive temperature coefficient heating device. Funny enough, I first came across the PTC heater when I was working on the Ford Transit way back in 1990 as a device to heat the cabin, a big cabin. So PTC device. But more recently, we're now seeing a heat pump, which is a great piece of technology. I would recommend understanding, the engineers understanding the concept of a heat pump. It's the ability to essentially, it's like a reverse refrigerator. You're cooling the outside air and drawing that heat into the vehicle. Okay, I thought there's something else I was thinking with the energy management system. Yeah, so balancing all of these systems needs to be conducted, and this is where we see a difference between EV and internal combustion engines. An internal combustion engine is, as within the vehicle, is a pretty inefficient device, and we've not had to worry too much about energy management within the vehicle. We haven't got to get too concerned about losing energy within the vehicle. If you find, you can find in some vehicles where the cabin is quite, I'm going to call it open, there's too many openings. So when you're cooling the vehicle down, the AC compressor is at a high load, okay? So the effective openings within the body adversely affect the AC compressor performance. It's on for longer, okay? Within an ICE vehicle with an internal combustion engine, this means that you will use more energy, but you don't notice it so much. With a battery pack, you do notice it. So we're trying to keep as much energy in the pack as possible. So that's a little bit about battery conditioning, but also touching on the energy management aspects. Battery management system. Okay, I think I alluded to this earlier on, the BMS. This protects the battery from operating outside of its safe operating area and limits. It monitors the balancing across the cells and will also bypass the cells during charging. And it performs a function to it, will drive the cooling requirements. It will communicate to the EV ECU, electric vehicle ECU, and it will also report the state of the battery in a display to the customer or through a wireless link back to the manufacturer. So this kind of display will display the state of charge of the battery. So are we at 100%? Are we at 50%? And we'll also support in the generation of the available range to the customer as well. Okay, so what's shown on this schematic are two charging elements: the what we call the normal charging connector and the quick charging connector. So the normal charging connector will run through usually through an AC alternating current system. So essentially, this will be something that you could plug in at home. You could plug in through an AC system with an increased current rating at home as well, because you'll find it in the home. There's a circuit for lights. There's a circuit for the cooker, for example, which would operate at a higher level. There are unfortunately a few different types of connectors, and we can see them here. And the most common ones are what's called the Type 2, and this combined charging system. And it's combined. You see the pattern here and the pattern here. That's the same pattern. That essentially is your AC input, and at the bottom, this is the DC input. So essentially, if you've got this kind of connector on your car, you can plug in for rapid charging and for AC charging into the same port. There are other systems. You can look up these details online, and you can see which of the different benefits and the kind of summarized here of the type 1 and type 2. You don't see many of these type 1s now, but you see a lot of the type 2s and this CCS combo. And we have this other system here for high voltage. It's usually known as CHAdeMO. So other elements of EV, I call it basic elements, but because EVs have typically started life as essentially a battery driving a motor, but the electric vehicle offers us a series of improvements versus the internal combustion engine. With our battery pack, and our battery pack is a significant mass in the vehicle. You can see, if you wanted to, a correlation almost between kilowatt hour and the weight of a vehicle, to see quite a strong correlation between the mass of the kilowatt hour of the battery pack and the mass of the vehicle. But that battery pack is positioned low. It gives you a low center of gravity. In addition to it being positioned low, it's also well inside of the wheelbase. So the dimension from the wheel centers is known as the wheelbase. And this battery pack is kept well within that area to put it into a safe zone. Okay. At the same time, the motor and transmission is also held within the wheelbase. And what that means is you don't have big weights sticking in front of the axle for a front-wheel drive, not for a front-wheel drive vehicle, but for what we'd call a north-south engine layout. A north-south engine layout would have the cylinders, say 1, 2, 3, 4, okay, and positioned ahead of the front axle. What that would mean, that would give you this understeer characteristic. So when you're steering the vehicle doesn't want to follow the line as well. It will understeer. You have to apply more steering to get it back in line. So we see the mass within the wheelbase usually on the inboard side of the axles, and that gives you this better agility. But as we get further along, when we look at all-wheel drive, and some of these all-wheel drive systems will have four electric motors, an electric motor for each wheel. And this gives you an increased opportunity to have this technology of torque vectoring. So applies more torque to the individual wheel as it's required. It helps with stability. It helps with agility and traction. So these are areas that electric vehicles can improve over the internal combustion engine around vehicle dynamics. And what's particularly useful for, let's say, a company like Mahindra, where we focus on SUVs, is that level of low center of gravity should also help with climbing inclines, and also with the angle that the vehicle can operate at. You can go online, and there's YouTube videos that Rivian have put in, have generated, and they talk about this, their big pickup, the big SUV, and the low center of gravity helping with the inclination of the vehicle and its ability to operate over real rough terrains. So a benefit for for every area of the vehicle, including economy, but very much around the dynamics of the vehicle. Okay, so self-driving cars. Typically, this is not linked to electric vehicles, but what we're finding is, is that people who are interested in electric vehicles are generally more interested in the technology. So self-driving car development, there are many manufacturers who are developing this. And here are some images of some vehicles. You're probably aware of the normal manufacturers. So you've got certainly Ford here, but many of the software companies, many of the startups are also looking to be able to apply this self-driving technology. And what you can see here when you look at these vehicles, and this is just a schematic and artwork of Apple, who are doing this kind of work, but kind of in disguise, is these kind of devices on the roofs. Okay, I'll come to that in a little bit more detail. But essentially, these are arrays of sensors that are used to measure the environment and to be able to provide information back to the system. But if we look at the history of driver assistance systems, so we start off with safety and convenience features. And typically these were vehicles produced between 1950, 2000s, cruise control. You can put the vehicle to operate at a certain speed, and the vehicle will continue on that speed regardless of what happens. Anti-lock brakes, okay, these will stop the wheels from locking when you're doing an emergency braking. But as you move further on, we get into more advanced safety features. Electronic stability control will keep a control of the power, the torque that's going to a wheel to ensure it doesn't spin. You've got blind spot detection. You've got little devices that will show in your mirrors if there's something coming up behind you that you can't see. You've got devices, forward collision warning. I had personally encountered this. I didn't have a collision, but I was driving a vehicle, and the vehicle decided I got a little bit too close to the car in front, and on the head-up display on the windscreen flashed a symbol. Yeah, that almost made me crash. But forward collision warning, lane departure warning. This is an interesting device. Again, I encountered this on a vehicle. Didn't realize the vehicle had this feature. And you're driving along a motorway, the vehicle not necessarily departing from the lane, but then the steering wheel would start to vibrate, or the seat would start to vibrate. The first time I came across it was the seat was vibrating, which is a very strange experience when you're driving a car. But lane departure warning. So these are things that just help to warn the driver. And then we start to get into some advanced driver assistance features, rear view video systems, automatic emergency braking, AEB. So this is pretty much standard now in new cars in Europe. And this will break the vehicle down to a complete stop without the driver doing anything. So the vehicle is sensing what's going on, realizes you need to brake. It may even realize you need to brake more than you're actually braking and apply extra load. It'll also sense the system and will operate, and that's be linked to this pedestrian automatic emergency braking. So the system can register whether it's a pedestrian or a vehicle in front. And as you move down, you can see the different types of systems here as well. This rear cross traffic alert is interesting. If you're pulling out of a junction and you can't see the system can actually sense what's coming from your left or your right. And as we move further on, we can see some further developments. Previously, I mentioned the cruise control. Here is adaptive cruise control, and this will then adjust the speed of the vehicle to take into account what is happening in front. Traffic jam assist. This will actually allow you to essentially follow the car in front to some extent. And self park, okay, as it's saying, this will allow the vehicle to self park. I had a similar feature on a vehicle which would control the steering. You control the brake, you control the clutch, you control the gears, and it would park the vehicle for me through the control of the steering. It would sense if a space was big enough and could help with parking the vehicle. But this is now, we're getting now into the future where we start to talk about these fully automated safety features and this highway pilot. And this takes us into some some definitions. And we have these ADAS terminology. Level 0, the human driver does all the driving. So level 1, systems that can help with either the steering or the braking or acceleration, but doesn't do them both simultaneously. Level 2 is almost a build on level 1. It can control both the steering and the braking and acceleration simultaneously. But the driver still needs to pay full attention. So level 3, this is where the vehicle can perform virtually all aspects of the driving task, but the human driver has to sit there and be ready to take control at any time when the advanced system request the human driver to do so. So I mentioned before about a vehicle with this self-steering, holding the lane. The way that this manifests itself is if the system switches off, you have to take control straight away. A little bit disconcerting when it's just a little light that flashes in the instrument cluster to tell you it's your turn now. But most systems insist that the hands were on the steering wheel, and it could sense if you'd taken your hands off the steering wheel. And this is some of the issues I think that drivers of Tesla with the pilot system have had issues with. We're now getting into almost full automation. Level 4, essentially the vehicle will take charge of everything, but only in certain circumstances. This is where it gets a little bit, let's say, concerning, but certain circumstances. A human need not pay attention in these circumstances. And level 5, this is where the vehicle takes over everything. All you almost need to do is to get into the vehicle, input your destination, and then the vehicle will take complete charge. So this is terminology that's been used in the industry to now to understand and to express to customers the level of automation. This probably isn't well communicated at this point in time amongst to customers, but you'll find manufacturers talking about them making the vehicle level 4 ready or level 5 ready. And what they essentially mean is that there are sensors in place, there is the processing in place, and the actuators in place to make this happen. But there's a level of nervousness about introducing these systems. So what are the benefits of ADAS? If I was looking back and thinking that, hey, you know, I like driving, and I do like driving, but there are many benefits. Most of all, safety. Most serious crashes are due to human error. And there are various scenarios. And if you look at crashes from dash cams on YouTube, and you can see these, you'll see situations where there is a crash, and in some cases, the driver wouldn't even see it coming. There was one instance where a vehicle was pulling off a slip road, putting onto a slip road to leave a motorway at a high speed in Germany, so doing maybe 150 kilometers per hour. He couldn't see his way forward, just assumed the road was clear because there was a lorry between him and the slip road, and he pulled straight onto the slip road into the back of a stationary vehicle. He couldn't see it, but the way these systems work is they could read underneath vehicle, get a line of sight, and that would have been picked up. So they will take away the human error by sensing what's going on. There's an economic and social benefit. Crashes cost a fortune, and there are some statistics here about the cost. Efficiency and convenience. This will, in all likelihood, smooth traffic flow, reduce traffic congestion, and it's saying here time and money could be spent doing different things. Mobility. There are many people who, through some form of disability, are not able to drive. So there are people who are registered blind. There are people with other issues who would be able to have a vehicle and to go to places that they couldn't have done before. So this would all be around ADAS level 5. And then this clearly would create employment benefits. In terms of the technology, so what this is, it's a lovely image that shows the different types of sensors around the vehicle and the different types of technology. So we have this radar or LiDAR, which is light detection and ranging. You have camera, and you'll have ultrasound. As you can see here, the ultrasound is really around low speed parking. What's not shown on here is, excuse me, is the sensing system, not the sensing system, the processing system that takes this information and starts to make sense of the world. But here's some of the features I've mentioned before: adaptive cruise control, emergency braking, lane departure warning. But the system can also recognize traffic signs, traffic lights, and make sense of those. And we have this nice feature of a surround view on the display in the car. You can see what's going on around the vehicle. Okay, and you can see the different areas as well, other areas. So LiDAR, I mentioned light detection and ranging. This is another terminology that's used in the industry, and people will confuse and not know what it actually means, but that's what this means. In terms of an image, this is the sort of thing that the vehicle is kind of picking up. It's scanning. It's using a device positioned on top of the vehicle. You would have seen similar on those images of the vehicles that are doing the self-driving. You've got a device that's rotating somewhere in the region of 1,000 RPM. It's there's a mirror, there's a laser in there, and it has a range of about 120 meters, and it creates this kind of picture of what's going on around the car. My first experience of this was as a passenger in a Rivian test vehicle in let me just think, 2018, going up the freeway. Sitting alongside a driver who was kind of not driving the vehicle. The car was driving the vehicle, and it was using this kind of laser and camera system to look at the lanes, look at how the traffic was moving. So, excuse me. So this is the kind of image that you can see from a LiDAR. I mentioned before about the image processing. You can have the sensors, but you need to make sense of what the sensors are telling you. This just to give you some indication of the operation of this. So this is the the premium version, operating at 320 trillion operations per second. I remember when I first graduated using computers with 16 kilobytes of memory and processing powers of some 280 bits per second, and that was good. But this is actually this is amazing, and this kind of technology is also being used in gaming cards. Okay, so essentially this is a supercomputer which is processing the data from the camera, the radar, and the LiDAR sensors to perceive the surrounding environments. It positions the car, and it can be able to operate the actuators to create this safe path forward. And as you can see, AI. So a lot of artificial intelligence, a lot of learning that's gone into this. These vehicles will drive millions of kilometers to understand what's going on, to come across the freak situations and be able to understand what those situations are. However, of course, there are issues, and you're probably aware of some of the problems that have happened where there have been fatalities. Here we can see a vehicle that's collided with a cyclist. Here's an Uber that's on its side, and this is pretty horrific Tesla Model X, which had been driving on the autopilot, and for some reason it had failed to pick up on this concrete barrier and had gone straight into the concrete barrier. And you can see the kind of devastation that's happened to the vehicle. And kind of based on that, and you can, this is almost hot off the press information. In the US, some of these vehicles, these self-driving vehicles that have been tested, have received a lot of criticism, and in some cases, people have thrown rocks at these vehicles as they're driving through their cities. And the NHTSA, who are the authority in the US, have provided this online tracking tool to help end customers, understand the safety and performance of these systems. So you can go on and you can, this is obviously the US. Here are some of the testing areas in the US. And then you can click on one of these and you can see what's going on. So this is Detroit Motor City. You can click here and you can see just what's going on a certain vehicle. I looked at this at the wrong time of the day because I think this is a vehicle that was probably stationary, probably middle of the night, I'm not sure. But you can see what's going on and you can see the data. The idea is it helps with participants and public understand the capability and limitations of these technologies. Clearly, they want to reduce the limitations as much as possible. Okay, so another element that is very much tied into electric vehicles is what we call this vehicle, well, V2X. It started off as vehicle to vehicle, vehicle to infrastructure, vehicle to, and then so let's just call it vehicle to everything, V2X. And this is essentially where the vehicle is communicating to whole different areas, okay, to the infrastructure, what's going on with the traffic system, what's going on with the excuse me, the traffic layout. It can communicate to devices. So I'm not going through this in any detail now, but you can use your smartphone to talk to your car, and you can use your car to talk to your smartphone, tell you what's going on. I have a very good friend of mine who's the CEO at Automobili Pininfarina, who owns a Tesla. He was able to let his wife drive the Tesla. She mislaid the keys or whatever. She couldn't access the vehicle through his mobile phone, and I think he was in Germany and she was in Sweden. He enabled her to operate the vehicle. V2X to pedestrians, okay, via the smartphone. To vehicles. Vehicles can talk to other vehicles. This is particularly useful, let's say, in poor weather conditions. You could find yourself in, we have a condition here called black ice. Ice that's not visible on the road. It appears just as the road surface. And if you imagine, there's a car which is in front of you or 100 yards in front of you, has noticed during the ESP that it's had to moderate the torque applied to the tires because of slippage. It could communicate that back to other road users, so that they could approach in a different manner. And the V2X also can communicate back to your smart home. This is a specific area, dedicated short-range communication. So this is where different manufacturers are working together to have different vehicles being able to talk to each other, which is another form of V2X. So these are a couple of technologies which are available to internal combustion engines, but very much figure, I think, in the buying minds of EV customers. Okay, so that's a little bit around the basics of the vehicle. I want to talk a little bit about this, I call it the new normal. We've moved into this new normal environment. We call it the new normal here now, where because of obviously the coronavirus, we've seen a complete change in our way of working. Ideally, I would not be here. I would be back in Chennai. And you can see here how what the effect this has had on global flight travel. Virtually everybody is at worst case 50%. Best case 50% reduced. Worst case, you're almost completely closed. I think the only line here, I think, is probably China seems to be operating more flights, but a big reduction in global flight travel. We've also got very used to this domestic work from home from March 2020 onwards. People are now very used to this. We're used to having no direct contact with work colleagues. We're very used to using these online tools to communicate. We've moved more into a flexibility in working. And we've also got used to not spending, in some cases, 4 hours a day commuting. It's probably not helping. We've got a lot of students online here, and one of the great things about, let's say, you're a first year student, is that meeting all your colleagues. What we're also seeing as well is that people are reluctant to use shared transportation. And this is just an indication of pre-COVID and today. Risk of infection has become the prime issue with shared driving, business commuting, and private trips, leading to an increase in preference for private vehicles. Okay, so the image I showed before talked about we're good to go on electric vehicles, but I think we have a question mark around shared cars and taxis. So this new normal would then indicate towards the future. So what could the future look like? I hesitate here because trying to predict the future, no, I'm not like that. but I can look at some of the things that have happened in the past to give an indication of ways forward. Battery packs. Battery packs are improving. The belief is we'll be looking at higher battery pack kilowatt hour as we progress forward. We'll be looking at a higher pack density, watt hour per kilogram, only around the 250 mark at this point. So commercial aircraft won't be able to get a win from this. And battery costs are tumbling. As more and more people are going for batteries, the prices are tumbling, the competition is opening up. So this is where we see this kind of progression. This is one estimate of the future, and it makes complete sense. ADAS level 5. Once we get into ADAS level 5, we'll have these self-driving cars and possible new future architectures. This is, let's call it artists' impressions of how things could look in the future. You know, you don't actually need a steering wheel anymore. You get into the vehicle, and the vehicle is just a means of getting from A to B and allowing you to spend more time doing those things that you want to do. And you can see here some renderings of different models, Mercedes, Audi images. What could that also mean is that, look, if we've got these very intelligent systems, there'll be no crashes. Things like airbags, not required. The body structure that we have around the vehicles, possibly not required. Maybe headlamps aren't required. So this is what the future could look like. So you could argue it's a vehicle architecture dream or nightmare. Someone of my generation very much understands vehicle architecture, or I very much enjoy vehicle architecture, playing off the different parameters. But this is a complete changing game changer. And what else could the future look like? I guess many of you have seen this, but in this city for the last 30 years, you couldn't see the mountain range. If we get to this environment, this clean environment, we have the carbon dioxide reduced, but we have this. We have the opportunity to see the beautiful country clearly. So I'm going to conclude now with what I'd describe as, I'll call it your future. What could that be? So as I've been going through these different areas, I don't know whether I've got engineering students, but there are many different disciplines that can go into, and I'm showing the Batista in the middle here. You've got so many different areas and inputs into the development of electric vehicles. We've got here laser sensing system. We got signal processing, virtual reality, which seems to be everywhere. Across the top here, you know, we get into a situation where at ADAS level 5, we will have legal and ethical responsibilities to take into account. What does the vehicle do when it knows it's going to crash? Does it save the driver, or does it save somebody else? Different. Electric vehicles are so much quieter. So NVH, noise, vibration, harshness, plays a different part. The AC compressor becomes an intrusive noise into the cabin in electric vehicles, and there's different techniques that are used to try and isolate and insulate. Statistics, there are so many statistics. I think back into, let's say, into driver behavior, into artificial intelligence, and chemists. Battery technology will not happen by itself, and a lot of this will come down to the chemists. And I'm showing on here ergonomics, I'm showing vehicle dynamics, electrical layout. So electric vehicles in graduate disciplines, there's so many different areas now that can find their way into electric vehicles, the ability to contribute to this, to the environment, to improve and continually improve. And I think one of the things that Valu said in his introduction is there's a lot more to happen in electric vehicles. There's a lot more development. There's a lot more innovation that's going to take place, and it's going to come down to you, to how you progress in the future. But essentially, it'll be your innovation, your development, and your skills that are gonna drive us forward. Okay, I'm not really sure how I've done for time here, but I've reached the end of the presentation, and I'd like to thank you very much for allowing me to spend some time with you, some of your valuable time with you. So thank you very much.
Thank you very much. Before we say a formal vote of thanks, shall we go for the Q&A? I think we have some more time, sir.
Yeah.
Mr. Sampson, Mr. Jose, are you there?
Yes. Hello,
yes,
Mike.
Mr. Jose will be moderating.
Hi, morning. So what we do, Wales, I've seen a lot of questions which is related to policy.
Okay.
Right, which I may not ask, because what we're trying to do here is to, help our participants understand what's happening in the EV space. Yeah. So
Yes, sir.
some of the questions, I think there are two parts set of questions, Mike, I will ask you. One is on the technical side, and the other is on the technology part.
Okay.
When I say the technical side, it means how we are making vehicles, what's the technology going into it. There are a lot of questions that's revolving around battery management systems, right? Fuel cells and lithium sulfur batteries. So could you sort of tell the team or our colleagues or our friends who are participating in the session as to?
So I did have a little section on fuel cells as part of a kind of a comparison. Essentially, in summary, a fuel cell is a much more expensive solution for a vehicle. In terms of the detail, the way that a fuel cell effectively works is it kind of converts the hydrogen reaction with oxygen into electricity. There are definitely, let's say, benefits, I think, at this point in time. The ability to charge the vehicle with hydrogen would be quicker than it would be to do fast charging. And some manufacturers are pursuing the fuel cell route. I think Toyota, I'm trying to recall now, I'm not sure whether Toyota switched on and then switched off the fuel cell investigation route. So at this point in time, the battery system and charging system is deemed by the industry as being the most, let's say, cost efficient. And if you bear in mind as well, we will be asking customers to step from the cost of an internal combustion engine up to a battery-driven vehicle. And then if you went from a battery vehicle to a fuel cell, it's a higher increase. So from a customer perspective, it's a jump to go to purchase the battery vehicle, and then it's an even bigger jump to purchase a fuel cell. In summary, battery chemistry. Okay, I am not an expert on battery chemistry. I showed the table before, giving a brief comparison, and there are different technologies out and about which are under development. We take our lead essentially from the cell manufacturers. So not many OEMs are actually cell manufacturers. We purchase the cells. So for example, Tesla take their cells from, I think it's from Samsung. Yeah, LG are a major cell supplier. So there'll be different technologies that the different cell suppliers are working on. But as I say, I'm a vehicle guy. Okay, I look at the whole vehicle and to package those modules, those cells in the most efficient way. So that was my focus, certainly in developing what I'd call the architecture. So yeah, I can't say any more on on the cells themselves.
Thanks, Mike. I think there's another question.
Okay.
This is again something to do with what kind of skills we sort of develop. So this question is posed by one of the possibly running in the minds of many of our mechanical engineers who are qualifying themselves. What are the few things, according to you, Mike, based on your diverse experience, that if I were to be a mechanical engineer, and I know that the future is going to be EV, not immediately, but over a period of time, what, according to you, should I pick up technically and otherwise to adopt to this new domain? I mean, this is electronics, this is embedded technologies, etc., etc.
Sure.
So,
Yep.
so what do you think we should pick up?
Okay, so yeah, I think it's a very good question. I mean, I'm a manufacturing engineer by background, okay, or my qualification. First couple of years were mechanical. But one of the key areas, so within mechanical engineering, you've got chassis systems, you've got steering systems, you've got vehicle structures, and you've got transmissions, drive shafts. These are all mechanical elements. You have the electric motor. One of the key areas too is around what I call mechatronics, which is the integration of mechanical and electronic control, electrical engineering. They're the things from a mechanical perspective that would be an area of focus, and there certainly didn't used to be a lot of these mechatronic qualified people in the business. Certainly, when I was at Bentley, I came across one person who had this mechatronics skill set. But within electric vehicle, there is still mechanical engineering is still a very, very sought after skill. You know, if you're going to look after the structure of the vehicle, and electric vehicles pose some very interesting opportunities for mechanical engineering, certainly structural engineering, where if you look at an electric vehicle, what we call a born EV, which started life as it's going to be an electric vehicle, is that when you look at the structure, what I call the sill structure, the lowest area of the vehicle, the side structure, this needs to resist the impact of the battery pack to the battery pack, together with the battery pack itself, the structure in the battery pack. So there are many elements of mechanical applications in and around the whole system, even the battery pack. You think the battery pack, well, it's electrical stuff, but it's a structural item. And as we progress further forward, what we look to do is to optimize the amount of space that's available in the vehicle for the battery. And this is where mechanical engineering will work on the structures to do that, front and rear, to maximize that amount of space. But mechanical engineering as a skill as a set within EV is very much part of electrical vehicle. You know, even though it's outside of, let's say, the ICE. Sorry, Jose, I've lost your. Hello, Jose?
I'm here, Mike.
Yeah, okay.
Go ahead.
The screen just changed. So it's not. I think very early electric vehicles were produced by electrical people, and then someone tried to make it into a car. The very early ones. But it's about bringing it all together: mechanical, electrical, electronic. And that image I showed at the end with the Batista in the middle and all the disciplines around the outside, it's cross-functional working at its greatest.
Thank you, Mike. We have a lot of questions, mostly, revolving around cost and price, which I don't think this is the appropriate forum to discuss. But
Charles,
another about cost, the price of the vehicle, so
Yeah.
that's India in infrastructure. There's a question revolving
it's
around.
kind of an interesting question because, sorry, Joss, because I mentioned before about relationships between different factors in a vehicle. If you look at the cost of a vehicle, cost of a battery pack, yep, there's this drive to get the biggest battery pack. And if you look at the Teslas, you look at the high performance vehicle, they want as much kilowatt hour as possible. But where it really starts to get very interesting is if you look at the smaller battery vehicles, if you look at the smart car, you look at the Mitsubishi small electric vehicle, these vehicles have got kind of 16 kilowatt hour. And they started at 16 kilowatt hour, and they're still around 16 or 17 kilowatt hour. So it's a change in the way of working, it's a change of mindset of people too. See, one of the issues with an electric vehicle is this range anxiety. People are, I can't get the range. And it becomes an issue. But as somebody owns an electric vehicle, they realize they don't need that range. And it's about your behavior, the future, not new normal, but the future. Look, if you're commuting 25 kilometers to work, 25 kilometers back, what size battery pack do you, I'm going to use the word need, not want, need. So there's these vehicles with small battery packs. They should be a low cost vehicle, but they've got a certain other image around them as well. But small vehicles, small battery packs to suit exactly what you want to do with the vehicle. Yeah. So you can have that high price battery pack, 100 kilowatt hour, and you can have 15 kilowatt hour. Yeah. So you could drive to work. You've charged it overnight at home. You get to work. You could plug it in at work. Where we work, Jose, we have the solar panels. Yeah. I mean, I don't think we have it right now, but you could plug into that and charge the vehicle up. There's also another issue around, we get into the vehicles becoming battery packs, power banks. That's another issue where you could own a vehicle and you could plug it back in when you get to work, and the system could take power out of the battery pack at a peak time and pay you for it, and then give you enough to get home with. Tesla are doing something like this. Yeah, it's a big infrastructure work, but sorry, Joe. So I thought it was a good question about the price of the battery packs. If you set it to what your expectations are, you can do it.
Okay. Another question, Mike, is it's about there are different kinds of energy systems in your EV vehicle. This is again a technical question. You have something which is moving, which is creating friction, and that's a different kind of energy that gets produced, right? Then you have your battery, which is creating a different kind of energy. Then you have your HVAC, which is creating a different kind of energy. How do you manage all these different kinds of energy and different kinds of needs of energy?
Right.
So that's a question. That's a very interesting technical question from one of the participants. Yeah.
That's an excellent question. That's an excellent question. So within MRV, we have the energy management team. and I've kind of said to them, look, it's not going to be about CO2. In the future, it's going to be about energy management. So for the engineers, energy is measured in joules. It's all in joules, whether it's friction or whatever, the energy is joules, and the rate of doing energy is watts. So an energy management you can do these simulations. So essentially, you will bring in all these different elements, all those things that are consuming energy. I looked at domestic energy, yeah, and the biggest consumer of energy in a house is the refrigerator. It is working all the time. So I'll try and convert this back into a vehicle usage. You need to, let's say, understand what's drawing power, what's drawing out of the battery. And there is a long list. And then you start to need to make some decisions around that. So if you look at headlamps, for example, if you switch to an LED design, then you reduce the energy consumption. Okay, so when your headlamp comes on, you've then got a reduced energy solution. But if you look at other systems, let's say use the air conditioning compressor, air conditioning. Does the air conditioning need to be on all the time, or can you pulse it? Can you switch it on, switch it off, switch it on, you know, and operate it at a different kind of reduced load characteristic, reduced load? I mentioned before about the vehicle communications. Yep. So we have around in a vehicle, we'll have things, let's say, communicating at 100 times a second. So tire pressure monitoring. If it's operating at 100 times a second, can it operate 10 times a second? So when we're sending out those signals, can they be reduced? So it's a really good question, and I think we're at the beginning of it. Okay, of understanding. We see in some systems, in motor systems, where if you're coasting down, that it's taking energy to overcome the flux within the motor. So what you can do is to provide some energy from the battery to minimize this flux resistance within the motor, and you balance. Is it worth doing that, or is it worth not doing it? So all the energy management systems, energy systems in the vehicle, you can balance, and you can make some other decisions. So, for example, double glazing. Some premium vehicles have double glazing. Gives the benefit of insulation. So if we spend 1,000 rupees on the vehicle, do we see a reduction in the energy?
Your audio.
Sorry?
Audio.
Can you hear me?
We can't hear you.
You can't?
No, we can hear you, sir. I don't think there's a problem. Do you have any problem, Mr. Jose?
It's better now, yeah.
Okay. All right. Any other questions, Jose?
Yes, an interesting question. You had shared with the audience here about, the connected technologies. So one of our young participants is a very interesting question, which is actually pretty a bit of a challenge for the automotive industry. His question is, with all the connected devices, there's a good possibility that you could hack into the system of a car. So with EV, your connected technologies, what is your counter mechanism to ensure that these things don't happen?
Okay, now I'm not an expert in this at all, but I have been involved in conversations with a few people who've essentially demonstrating their system. And I remember having a conversation with a guy called RJ Scaringe, who is the CEO of Rivian. And he was talking about that very same thing, about using a smartphone, rolling codes are in there so that it's protected. But I'm not an expert on this at all, but I know that these manufacturers do these things to overcome this issue, and there have been cases before, I think, where people have hacked into a car. And I think the manufacturers have recognized that this could be a potential weakness and are putting actions in place to stop that from happening. So I can't really give you an answer in the detail, but if that the particular person's asking that question, I would assume that he's aware of the issue and would probably have some good ideas.
Thanks, Mike. So there are some questions about, how do you, there are these challenges that you have in the batteries by itself. For example, one of the participants is asking, how do you sort of prevent the discharge of an electric battery, and what's the technology or mistake-proofing methods that you have possibly built in your battery technologies?
So if you like, there's two sides. One is the battery management system. I'm not sure we're talking about the battery management system or whether you're talking about this rapid, this thermal runaway. If we get to an ultra rapid discharge, that's where we have the heat problems and the thermal runaway. So within different manufacturers of battery packs do this analysis. I've seen them done, let's say, sophisticated manners, and I've seen them done in less sophisticated manners where someone's taken the pack out to the car park, damaged the cell, and seen what's happened. Yeah, if anybody's heard of Remac, maybe that's something they might have done at one point. So you've got that kind of side. So when a cell goes into this thermal runaway, they have protection devices in and around that cell. In terms of the battery management system, that's the job of the battery management system. So it monitors the condition of every single cell in the vehicle to ensure that we're not getting problems. And that's essentially at a high level. I can't get into the details of this because you're now into some detailed software analysis, detail sensing. One other area too is how well the cells are actually joined to the electrodes, and the thermal management that takes place there. That sort of simulations that go on to ensure a really good connection. So there's kind of there's three kind of basic areas there that I'd look at, but the BMS is the most important. Well, they're all important, but the BMS is probably the most complex element of that. And you'll see, if you look at a battery pack, you'll see what looks like a big lump of module pack, but this would be the big area, which is the BMS, the battery management system, which is monitoring all the cells. I think it's like 3,000 cells in a vehicle.
Mike, though it's not directly a question related, I think some of the audience members are asking for the PPT, which I think we will discuss it amongst ourselves, what we can share and what we cannot share at this point of time. Yeah.
Mm-hmm. Yep.
Just more. Another question, Mike. According to your experiences, what are the few skills that somebody should immediately pick up, both in terms of the hardware and in terms of, if I have to pick up some software skills? With whatever experience, I know it's tricky question, but just something which is coming top of your mind. I mean, you've been having experiences with
top
some
of my mind. Okay.
And second, I will ask you a very personal question, a very interesting personal question, which has come after you answer this technical question. Yeah.
Okay, that could be okay. So, the top of my mind, I always find that there's a couple of skill sets, which maybe it's a little bit of a side to what you're talking about, but it's always something I'm very strong about here. Is about decision making and about problem solving. Okay, as your as engineers or as graduates, you're going to be making recommendations for a way forward. And people talk about, they get very involved in a particular solution. And Valu made a good reference this about being creative and generating options. And then it's once you've got that left brain, right brain going, you take those creative ideas, those innovations, yeah, and then you're going to choose the best way forward. And that's when you drop into this let's say more formal process, decision making. I would recommend that people focus on that. And there are kind of standard tools and techniques. I use a decision matrix. We determine the requirements, we prioritize the requirements, and then we will evaluate the options against the requirements. Okay, I would put that to every single person in the call as a student. Okay, and not to get carried away with one idea, because you can flay an idea to death and it's just in the end will have no merit. The other thing is about problem solving. Human beings are interesting creatures. We've come through many thousands of generations, and some of the problems we've solved have been quick, knee-jerk. Yeah, and this works for maybe 90% of the time. Okay, but there's some nasty problems, some difficult problems through which you kind of need to go through a problem-solving process steps. That's kind of what jumped into my mind when you were talking about the kind of skill sets. And I think these are probably more important than some of the technical areas to my mind. I'm not a specialist. Maybe I was more of a specialist in problem solving and decision making. I used to train it and do it at the same time. And people would come to me and say, Mike, can you help us with this? And I'd be that person in the middle, the neutral person, taking people through that kind of decision making and problem solving process. I'm not sure if that's quite answered the question, but that's definitely something that I would say to everybody to get involved with. To if there is that, look, if it's part of your course, focus on it. If it's not, find a way of looking at decision-making techniques and problem-solving techniques.
So, Michael, it's again not a question to you, it is my response. There is a question which says, any courses which could help us to enter the R&D of EV? So to all the participants here, so we have a session by Dr. Shankar. If I recollect the date, it's going to happen on, just give me a second. It's going to happen on the 6th of February. Yeah. If you all can participate, possibly we can give you some inputs as to what we are doing in the Mahindra's Technical Academy. And we'll also help you with some resources where you could access them, right? So that's the input on this. So now coming back to the personal question, Mike, it's a bit tricky question. Okay. So the question the audience or the participant is asked is, you worked in very marquee brands like Rolls-Royce, Bentley, and you worked in Europe, right? You worked in a high-performance car as well. Why did you choose to come to Mahindra, and that too to down south to India, to Chennai?
Okay. Yeah, I've been asked this question a few times. Yeah. So the brands I worked on, Rolls-Royce and Bentley, and say Automobile Pininfarina, very select. And what I found is that a lot of my, part of my skill set that I think I have is in problem solving, technical problem solving, but also in data analysis and in what's what I'm looking for, almost statistical control, process control. And I was doing this kind of detail work on Bentleys, and you know what? You realize that the customers probably won't even notice. The only person who noticed who were doing a good job was myself and the guys who did the audit scores. So there's a lot of time and effort going into what would be a very small number of products. And the opportunity to work for, let's say, a bigger manufacturer will be the ability to kind of apply those techniques to and way of working to hopefully give more of a benefit to more people. So, and in the past, I worked on commercial vehicles. People might not have spotted that. And I got great enjoyment out of actually delivering something to the customers. We did something where we had this thing called a customer council. The customers would come in and see the vehicle, and there was, I'm going to say ordinary people, okay, and you were providing benefit to more people, and it just gave me I don't know, tremendous excitement to be looking at that kind of a different industry. Which have that, you'd have a wider appeal, more people involved, more people who can benefit. So, and I guess a challenge as well to move out of that environment to a different environment. I've been in Bentley for 18 years. Unbelievable. Okay, so why Chennai? That was the question. See, I know only after I've joined that I've
There are multiple questions, Mike, if I may ask. Why did you move out? Why did you come to India? Why Chennai? And what's been your experience?
So the one I moved out, let's say, to the manufacturer. Why India? Well, actually, Mahindra approached me. So that was essentially it. I was let's say working away or whatever, and I got this email, would you be interested in? And I thought, yeah, I'd be interested in. So that was how the kind of it coming to India, and I guess MRV is located in Chennai. But I like India. I like Chennai. I like the people. I like the way of working. And find it a really kind of just a respectful way of working as well. So I remember going to Chennai, and people, let's say from other parts of India, would be, let's say, have observations about the south of India. Which part of India are you from, Jose? You Kerala?
From Kerala. Yeah.
Kerala.
God's own country, yeah.
God's own. Yeah. So I'm kind of aware of that, but I do like being in Chennai. I do like being in India, and I've not traveled as much as I'd like to, but I've been to the normal places like Goa. I've been to Delhi. I've been to Mumbai. I've been to to Agra, as you do, and to Kerala a few times as well, and to Hyderabad. Yeah, so I've been to many places. So I like India, and I'm missing not being in India, and my wife is missing not being in India more than I am.
Thank you, Mike. I think it was useful. I know in a little time we could just give the macro overview of what goes into designing, making an EV. Of course, we couldn't share something which is very proprietary and which is some of the intellectual property things that is, essentially belong to Mahindra. But I like to, Vales, if you don't mind, I have a small, the skill sets that the participants could pick up, which in our opinion are some of the skills that could be required in the near term. So this is a research topic. I'll just flash it in. I do not know if it can be seen. So this is my screen.
Yeah, you can share your screen, sir.
Is it visible?
Yes, I could not see your screen, but there is an option for you to share your screen. I'll do that. So what I'm going to do is I'm just going to show the audience. Oh, that's great.
Yeah. Is it visible now?
Yeah. Yes, sir. Yes,
so
it is.
What our participants should pick up is, these are the skill sets. Somebody asked what kind of skill set should we pick up. So these are some of the things. It's a combination of technical and a bit of personal, and also the business side. You can just pick it up. The one which I'm showing, fast growing skills in manufacturing, and this is based on a research. And what I'm showing you is they are courses that's available on your MOOCs. So massive, the open courses that's available. If people have seen it, I would like to stop sharing. Can I stop sharing?
Yes, if somebody wants to take a screenshot, they can.
Sure.
Fine. Yes, sir. Now the screen has.
It's gone?
Yes, it's
Or they want some more time, or?
Yes, of course, sir. Certainly, it will be a treat for them because we're sharing a very valuable information.
Yeah, I'm sharing it once again. Is it visible?
No.
Now?
No, sir. No. Yes, now
Yeah.
it is. Yeah. Maybe you can allow some 10 seconds for them.
Sure,
if
sure.
anybody is interested in taking a screenshot or make a note of it, please do, because it's very important points which will be of great use to you. I think they are done. Yes, sir. You can move. You can move on.
Okay. So to all the participants, I hope you can see what we have got here.
Yes, sir. Cube.
Can somebody respond on the chat?
So do you want
anyone from the audience?
Participants?
Any one of them could respond.
Okay. Maybe in the chat box they can do.
Yeah, sure. Yeah. So good. I want that person who said Rubik's Cube. How many faces do the Rubik's Cube have? How many faces?
You can type it out. You can
type
it out.
Good. Very good. So, as a human being, how many phases in your life do you have? What are your life stages? How many life stages do you have as a human being? When I get the correct answer, I will respond. Many say 3, many say 4. How many life stages do you have? 2? Somebody is still a small child. 6. So I have, I'll tell you somebody who said, I say Ayush who said 6, Mohammad Syed who said 6, Jayant who says 6, Parag who says 6. Yeah, good. So we'll stop with that. Good. I have said Shanu who says 6, Raga who says 6. 6 is the right answer. Now, why I'm showing you this Rubik's Cube is you're in an important phase of your life. And we call this as adulthood. Our job as from the team of our technical people and people who are here is to explain and move these things for you. Now, all these different things will come to a particular pattern and color, right? So our job is to make those movements happen so that there's the right pattern and you pick up the right skills, right? The whole idea of this session is to give you those inputs so that all the faces of the cubes, which is in your adulthood, what we call adulthood, which is a big stage of your input for your future development, right? You pick up and soak in all the skills that is necessary to make your career a great success, right? So that was the idea of this session, along with the Vikatan team, where we thought we could sort of help you understand in terms of what are the few things and for all the skills that we need to pick up for the future, right? So thank you, Wales.
Yes, sir. Thank you. It's our pleasure.
Right. Thank you from our side, and hopefully we catch up with the participants in the next time. So I saw someone write Arumugam. True, it is 6 faces that we all have. Only thing, it is PHASES, not faces. Right? Right.
Thank you,
That's
sir.
that's
Thank
it.
you.
That's it from my side. Anything else?
Yes, thank you.
Yes.
As I before we move on to the vote of thanks by Majid Khan, our chief business strategist. I just have a announcement to make. We have 4 exciting sessions which are equally exciting like this one. I sincerely wish all the classrooms in our country, be it high schools or the colleges, should be as exciting as it is, because I think the people are excited today because the students are not just students, they are also enthusiasts, automobile lovers. They are thrilled by by the sound of the car. So that is the level of excitement they have, because day in and day out, we as a motivated journalist, see these people on the road. Whenever we drive a new car or a new vehicle, the people will stop them on the road, and they will ask a lot of questions about this vehicle, the mechanics and everything. So the people whom you are talking, Mr. Smith and Mr. Jose, are the people who stop you on the road when you travel in a new vehicle or a new car. So this is the level of their enthusiasm. So that's why, apart from this Zoom, there are thousands of people who are watching this program live on our YouTube channel and also in our website. And this is going to be in our site for times to come. And there are also people in this group who are the students who are also keen on certificates, apart from all the enthusiasm. For those people who are very keen on getting the e-certificates, I should say, you need to attend all the next 4 sessions. Those 4 sessions will be equally exciting. What all the topics is going to be and who are the speakers, because we already publicized all those things. So I sincerely wish, and I sincerely recommend you to attend all the other 4 sessions as well, that are going to come up in the next 4 Saturdays. And you can also spread the mouth by word of mouth, that with your colleagues, your friends, and your neighbors about this program, this session. Because if you sincerely think you have gained, please spread the word. Let us ignite a passion for science, a passion for automobiles among our friends. Now I invite Mr. Majid Khan, to our chief business strategist, to convey his vote of thanks.
Thanks so much, Whale sir, and good afternoon to all. Honestly, couldn't have asked for a better start for this weekend. My sincere thanks to everyone at Mahindra and Mahindra for giving us an opportunity to partner and take this knowledge sessions to thousands of participants. Mr. Smith, thank you so much for this enlightening session. I haven't seen our readers this engaged. We've done close to about 200 plus online events in the last 8 months, but I think this is one of the most engaging sessions we've seen, and I'm sure our readers must have gained immense knowledge by this session. And especially thank you so much for those kind words about Chennai. We definitely want to have you back, and be great to meet you sometime soon. Jose, thank you so much. I'm sure it must have been quite a task for you to keep tracking all of those questions coming. And thank you so much for compiling and having a nice Q&A section. And the last way you wrapped it with the Rubik's Cube is definitely was very interesting. And I'm sure our readers would have gained a lot more from it. Veluswamy sir, it's always a pleasure working with you. Thank you so much for another wonderful session, and always thank you for those words of wisdom. Keep inspiring us as always. Our readers, thank you so much. Just like the way Vail sir had said, it's been a busy 2.5 hours for us. Quite a lot of active participation across Zoom, YouTube, and on Vikatan.com. We've had close to about 14,000 plus registrations, and I'm sure you must have benefited with this session. Looking forward to have you all in the forthcoming session and for more active engagement. And lastly, as always, thank you so much, Vail sir, for pulling this up, and everyone at the events team and the editorial team for giving such an awesome event as always. Thank you so much. Looking forward to for more such events. Thank you so much from Vikatan.
Thank you everyone. And the Google form will be live for next half an hour. The people who have not filled the forms, you please go ahead and fill the forms, and see you on next Saturday. Thank you everyone, Mr. Smith, Mr. Veluswamy, Mr. Samson Jose, and Masjid Khan, and Preetham, Tulsi, Tamil Tendral, and every one of you. Thank you very much.